Hello everyone, I welcome you to the video 5 of this section, which is titled Going Beyond Traditional Approach, Applying Machine Learning Algorithm or Technique to Forecast Tail. So these methods allow us to introduce all the departments and stores, including the features in our modeling, which is one of the limitations of the traditional method, in the sense that you have to use the dates only and also the store. Okay, well, one at a time. So we're going to start by importing the relevant features. Okay, so the description is there. Additional one will be imported later. So let us also set the directory, and we can list the directory. So to see the contents, let's start by we have not imported our modules. Okay, so that has been settled now. Okay, so we have set our directory. Let's list the content. Okay, you can see the content there. Remember, I use this absolute directory, so that often happen if you have not set your working directory. So now, because I've done that, I can shorten it and it will give me exactly the same result, which is what it has done now. So what we are going to be doing now is to load the 1 month 6 forecast data. So we have already seen the content here. It has train.csv features and the like. So let's load it, and let's start also by checking the length. How many records do we have there? So we have 421,570 records. Let's see additional information about it. So we can see the content now. We see the store, department, date, weekly sale, and its holidays. So those are the features, or you can refer to them as columns or field, and there's no incidence of any one of them having missing value. Some are in integer while some are in character format. So for example, date now, and this has to be converted. The bool is a kind of binary yes or no, true or false kind of data. We will see the content, the values better now by saying train underscore dataset dot end. You can see what they contain. Okay, all right, it's time to prepare the data set for modeling. This is what we are going to be doing here, is to list the maximum day by store and department, since we'll be using train data sets only for train and test. It is logical to check whether they end at the same time. So what I'm trying to say there is that we are not going to use test data set because we don't know the outcome, because this is a competition data set. But what we can do is to take that train data set. We have 400,000 plus records, which is enough. So what about if we just take split the data set and use part as a test? We know the outcome, then we can be able to do the evaluation. We can evaluate our model, which is advantageous for us in this context. In the course of splitting, we'll be using dates. So we want to use a uniform date. That means the sales ending on the same date. So for us to be able to do that, we are going to take the maximum date. So the date which all of them have got records. So the popular date is 26th of October 2012. All right, so let's see. Also, let's check how many records out of all these ones hence had on the 26th of October 2012. Okay, by running this line of code, we'll be able to achieve that. Okay, so we have 2,959. And remember that this has gone down drastically because we are only considering the end date. So in a way, all the commands that we have run prior this time has grouped the records by store and department. So you must know that that's the reason why the data has gone down. We still have 400,000 record, but in this context now, everything is group. Okay, so we have done that. From the output above, most of the records by store and department end on this particular date, that is 26th of October. Let us view the ones that did not end on our date, on the popular date. Okay, there's a number of them, so you can see the different dates on your screen there. So it's time for us to filter the data to get rid of those ones that didn't end on the 26th of October. But before you do any filtering or merging, it's a good practice to keep a tab on the number of records you have before you engage in the art of filtering. Okay, so we have 331 of them. This is the aggregate one. Okay, so now this is the time to retain the records of store and department that ended on the 26th of October. Okay, right. So we have done that. So we have less. So here is to check the number of records that we are left with after the filtering. So we are talking about the non 26th October. So now we have filtered everything. So we are left with 295.9. Okay. So now let's view some of the records again. Okay, you can see the records, the new ones. You can see the end dates there. There are still a lot of them. Okay. So what we are about to do next is to concatenate store and department to create an identifier column. So this will make our life a lot easier. So the concatenation in this case is to just create an identifier. You must note that it's not that we are joining any data set, because there's another kind of concatenation in pandas. So by running that command, you will be able to get that. So this is what we have achieved now. So we did a concatenation, and how were we able to achieve that? So the store value is in number format. That means it's an integer. Department too. So what we first of all did here was to cast it to convert the data format to string, the two of them, and also to bring in uh, the, the dash sign. So and also to concatenate with just plus. You cannot plus two texts together. So when you plus them, add them together. So what you get is a concatenation. So this way is useful when it comes to merging and you don't want to bother about yourself about using store and department. So you can just use it like that. So because we'll be filtering the main data set, the one that runs into 400,000 plus, it's advisable we create exactly the same column, the same features, having the same name. So if you don't do that, you won't be able to merge your data set, and you will not even be able to use enlist command. So we are now in the max train data set. We want to get rid of the redundant features. Remember, we want to merge. in our original dataset, we already have all these columns. If we merge, it's going to be a problem because it's going to see duplicate features and create extra ones. So we don't want that to happen. So that's why we are doing what we are doing now. Okay. So we want to restrict the original data set to 26th of October 2012. Remember, in the train data set, we have 400,000 plus. To be precise, 421,570 records. The max string is a filtered one, so we have already restricted, but in the train data set, it has not been restricted. So the plan now is to use the filter one to restrict the original one that we are here to filter, and we're going to create a different data frame, which is project underscore dataset. This is going to be created. Okay, so as our usual practice, we want to change the number of records before we do any kind of merging or any kind of addition. So that we have already done here. And now we're going to adopt two methods. The first method is just to merge. We are merging on store underscore department feature that we just created now, and our approach is to do inner join. Okay, after joining, our records have reduced drastically to 400 411,664. Okay, let's use a different method. The first method here is to merge with data frame. The second method is to use in list. So that means we are saying the records that are in this column. Yeah, so you have to, as you continue, as you do all these projects on your own, you have to decide which one you want to go for. Remember, when it comes to Python or any of these programming language, you can use whatever approach or method you like. So you can use the complicated method. If you want to create a function to do this simple stuff, you can use it. You can use whatever it's there's you have flexibility when it comes to writing codes like this. So you may decide this is the method that I want to do. Okay, let's check the number of records again. So we are using this max string 2 now. We are using project datasets. Alright, so we now have only store and department and hence. Remember, when you run group by, you are grouping the data set, so don't expect to see 400,000 record. So we are going to do another merging. This time around, we don't have the choice of two methods, so we have to do it one way. So let's read the data set first. Remember, I will show you in that folder, in that directory, that we have features as well. Okay, so we only have 8,190, which I believe will cover most of the stores. So this one is at the store level, it's not at the department level, so don't expect to see 400,000 plus. Alright, so these are the features we've got here. We also have store and date, we have temperature, we have fuel price, we have markdown, the CPI, unemployment, and it's holiday. Alright, let's view the records. Alright, we can see some of them have got missing records. Look at them here. So when you see the total is 8,190 and you see some of them are less, so it's indicative of the fact that they've got missing record. Okay, so in this video we'll not be dealing with the missing data because our algorithm will be able to handle it. But when you have missing data, there are many ways of handling that. Is either you drop the record, but remember this is a time series kind of project, so we don't want to drop so that we not destabilize the dates. What you can do is to impute. You can drop the instead of dropping the records where they are missing, you can actually drop the columns, or you can impute. You can look for the median value, the mean value, if the data is normally distributed. But most often than not, you don't have that kind of privilege of having the data normally distributed. Okay, so let's view the project data set because we're going to merge them together. And also let's check the number of records that we have in the project data set to confirm. So as I said earlier on, before you merge together, you must always check the number of records because in the course of merging, you may introduce unnecessary record if you don't merge correctly. Okay, so we have 41164. So now it's time for us to merge. We are going to overwrite this data frame. We don't want to create an additional one. So this is our project data set. We want to merge it with feature data set. And what is the approach? We want to do left join. So we are bringing the record from the left. Our left is the feature to the right one. And we are only joining on store and department. All right. So if you don't want to concatenate, this is another approach. You remember what we did earlier on? We concatenated store and department. So if you don't want to, you can just list them like this. So we don't want to concatenate, so we want to use store and the date. So why are we using date? If you look at what we have here, we have store, we have the dates. So and you see. So if we don't use date, it may introduce problem. You are going to have duplicates because the data will be replicated. You can try it on your own and check your lane. You will see what I'm talking about. Okay. All right. So let's do our merging now. Oh, okay. Uh, it's complaining about this project X. So as I said, we will overwrite the data frame, so we don't need any X anywhere. But if you feel you want to preserve the old one, you can go ahead and use a different name. Okay. Now there's a problem. The problem is that I ran this twice. So I ran a main data set on another mesh data set. So it's throwing me an error or duplicate name. So how do we resolve this? Okay, one way of resolving it is to go and run our code all from the beginning. I think it's safe to do that. So how do we run our code from the beginning? So you just come here, click on the cells and say run. So I'm going to put my my cursor in this cell, or let me put it here and say run all above. Okay, then I will now say run this. You see everything is normal now, but one thing that's happened is that it has changed my column value. So this is a kind of problem that you come across, so you don't need to be alarmed about this. You run into this kind of problem. The beautiful thing is that there's a solution. Is holiday is still 2 because in the other data set I have is holiday. So if I don't want this 2 is holiday, I just have to get rid of one of them. Okay. So if it's got 2 columns, the same column, so what you must do is to first of all delete one, most especially in your primary, you can leave the column in your primary data set. That means your master data set, the major one. In this case, our major one is project data set. Okay. When it comes to machine learning, so you may need to create additional features. You can, where do you get additional features? You can create an additional features from your existing data sets intuitively. So you must be intuitive to be able to do that. And also you can get data set from other sources. For example, if I want to capture seasonality, I can look at the weather. So if you go to many websites, they will tell you, give you information on season. Okay, so you can think about, okay, winter, spring, autumn, and summer. So all those have impact on your model because the way people shop. The same thing with all those festive period like Easter, Christmas, New Year. So you can create features like that. You can source it or can create it. So what we want to do is to create it. So we want to create features from week. So how do we do that? You can see the command here. So we are factoring the data formatting approach. What I'm doing here is to just to ignore all this one inside. Let's create week. Done. Create month. That is done. Year. That is done. That is done. Okay, so everything is done. So if you want to see the newly created feature, can go like that. Just scroll to the left. We have week, month, year. So which is just the splitting of this date values here. Okay, so they are very essential. So they can give us a kind of pattern. They can tell us something about seasonality in terms of the holiday, just like we see in the previous videos. For those of you that started with me from the first video, I explained the trend, seasonality, and the like. So by creating this kind of something like the month here, the way it can help you. So now another way of creating additional features when it comes to this time series data is you can lag. We call it lagging. So, but before you do anything lagging, you must sort your data set, and before you do that, otherwise it's going to be picking data from the wrong department or from the wrong store or using different. So here we want to sort by store, department, and dates. So remember we have concatenated, we have this particular one. All right, you can create as many lag as you like, so you are not restricted. So in this context now I want to create 5, so that means I'm going back 5 times. And from this lag you can create moving average to supplement your data set, to augment to add more features to your data set. The interesting thing about time series, those traditional method that I went through with you, is that you can use them to create interesting features that will boost your model as well. For example, you can, all those naive method, if you like, you can use them. The lag, you can use the moving average. So by creating lag to compute the moving average is straightforward. We are not going to be doing that now, but on your own, while you are on your own, you can do that. It's pretty straightforward. See? Alright, so look at my lag column now. You can see what has happened. A lag of 1, a lag of 2, a lag of 3, a lag of, and I've already replaced all these ones that do not have anything with zeros. Okay, all right, so I've used 0, but you can be ingenious about that. You can say, okay, why should I put 0 if I'm not going to start at this particular year? You can say, okay, let me put the average, month average or year average. There is also allowed. So this, for this analysis, we are not going to start analyzing in 2010, so I don't need to worry about this 2010 value. So let's look at the tail. There's nothing like, let's look at the lag again. So there's nothing like 0, so we are safe. Alright. So we can plot do a kind of data exploration to do the CD distribution. So I'm not going to do that now. Now we have prepared our data set. So we're getting to the end, not to the end per se, but to the main modeling aspect. So what we want to do is to create the train and the test data set. So here is our train data set here. Let's do this. You see how we are creating the data set. As I said, we are not starting from the year 2010, we are starting from 2011, the beginning of 2011 to before these dates. Remember this 26th of October week. So we are not going to use it. So it's going to be our test data set. So we are selecting all the data which give us 200,000 plus. Okay. So here is our test data set. So look at the command I'm using to separate them. So here I'm not doing a kind of random creation. I'm not splitting. I'm not engaging this scikit-learn command for splitting. So I'm just splitting based on date, because when you are working, basically when you are doing a forecast, you want to see what the results will be in the future, and that's basically what I'm doing now. It doesn't make sense for me to do a kind of random splitting in this context where I have dates. But if you want to do a random splitting rather, the choice is yours, but just know what you are doing. So removing the target variable from the prediction. So this is part of preparing our data set for modeling. So what we want to do is to remove the target features. So we start by creating a features to hold our identifier. So we are using this IDS is holding our identifier. Once we are done, we come. Okay, so here we are dropping store department, weekly sales, date. So dates will not be of use because it's a date the model will complain, but we've already created a proxy in terms of year, month, and week to handle date. So weekly sales we are removing because that's the outcome features, and the store department we are removing is an identifier we've already stored, and we have something to denote store and department already in the data sets, so we have not removed them. It's only that we created this process. So train process data for training. Okay, so this is what are we doing here. We are storing the weekly sales here. What are we doing here? We are keeping the columns that do not include all this one. Mind you, we need to do something about the holiday. We have the ones that end with suffix underscore x, which is here. So we don't want to use the two because they are basically telling us the same thing. So what do? We put it here for deletion. Okay. All right, it's already out. Okay. It's not that we cannot add it, but the problem is that we run to the issue of multicollinearity. What is multicollinearity? Multicollinearity is basically a situation where your two features that are telling you basically the same thing. So we call them multicollinearity. And how do we check multicollinearity? By using correlation matrix. So we are not going to do that. So for this, but that's one thing to note. Yeah. All right. So look at our records. This is the one for training. This is the one for testing. So what we are doing basically, this is our outcome feature, and these are the other features. So if you want to check, you can just say xtrain.ed, which will give you everything. Okay, this is the model building. So we are going to use XGBoost. So remember we have no values there, but XGBoost has a way of handling the missing, the blank or the null record. So don't trouble yourself about much, and we are not going to be doing fine tuning as well. All right, so but these are the things you can do on your own later. All right, so as I told you in the first practical video, if you see asterisks like this, it's asking us to wait. So you don't need to trouble your Jupyter notebook, it has finished. So what we have here are the parameters that you can tune your own. So it's giving us the default now, what it thinks is right for this model. So there are many ways of doing um, of fine-tuning your XGBoost. So most of the algorithm, when you find them, you just tune them to fit to what you are doing to get optimal values. Evaluation matrix, we import the additional module, and we make our prediction. Two, 6, 4, 5. That is our. So that is the value of our RMs. Yes. So how does this evaluation work? It's just the difference between the residual, you are measuring distance, we call it residual, the predicted value versus the actual value, the square root, the difference. So that's what is happening there. All right, let's predict with the test one. Okay, so we have predicted. All right, so when you create a model, then you can also predict with it as well. So we are predicting with the test. I think these two, they are basically the same, X test and this one. They are basically the same. So let's call this one our submission. So if you see this submission, I think I created another one, but let's okay, we can still leave this one, or let's delete it and use the other one. Let's now go to the feature importance. So if you look at it, the feature that is contributing the most is lag prior 1. So that means the first lag, followed by weak, followed by lag prior 4. So you can see the essence of creating an additional features. So that's why rigorous feature engineering is required. It makes you to have an advantage when it comes to machine learning competition. You can create features from the existing data. You can bring in more features. You can do a lot of things to the features. You can, for those ones that are not normally distributed, you can transform them. You can do log transformation, box cos transformation, square root, inverse, cubic, whatever the approach I think is making the data to be normal. Right. Result comparison. Okay, so here we are going to do the prediction. It's just the prediction that I cancelled the other that I was done previously. So let's do it now. Remember, in this contest, I'm rounding. So this is basically the prediction I'm doing. This one that you see here, this is a numpy command for rounding to the nearest whole number. You can see the impact here. All right, this is my submission, as I said we would address here. So you remember this IDS, I created it to hold the store department column, and this is my predicted values, which is the test predicts here, this one here. So now I'm bringing the two of them together. Okay, you see I've brought the two of them together. The length is 22959. You see I have the store department on one side and the others. Okay, that's my test.ed, the original one. One thing you will notice is I don't have the outcome features in this. So this is the one I call the prediction data set. This is the original, the test. You see this one is starting with capital letter. It's the original one. It has the outcome and the identifier as well. So what I want to do is to compare my results with the original one. So what I'm doing is just to store it in a prediction data set, then merge with the results, this one here. Okay. So I want everything to be in whole number, so that's why I'm just doing a rounding up. I think I've done that previously as well. So this one is not necessary because that's already been done. So now let's see the difference. So we are looking at the absolute difference between the predicted and also the weekly sales. So we want to see how much does it differ from, let's use a big number here. How much does it differ from 10? Or let's say 5, 10, and 20. Because the number varies widely. So for a difference of, we only got one that exactly match. So the variation is quite high. But let's look at the difference of 1. Remember the difference of 1 is 5. 10. Then let's look at the 2 1, which is a difference of 10. 23. Now let's say difference of 3, that is 20. 52. Okay, so that means there's still a lot of work. To a lay person, maybe to your boss at your place of work that don't understand the metric, this is a way of showing them the difference. Okay, how much you miss the target. But that means there's still a lot of work for us. There's so many things we can do to improve this model, but we are not going to cover that in this time around. So thank you for being part of this video. So I will see you in the next video. Please stay tuned.